Okay, everybody, this is Mr. Karlovsky again, and we're just going to formalize our notes so you can do the homework. So from the earlier video, what was the definition of an ellipse? It was the set of all points whose sum of distances from two fixed points is constant. All right, and that was that string definition. All right, we've got our equations here. And please note that they have to equal 1. We might see some examples that don't equal 1. Well, what do? You just divide by whatever the value is so that it equals 1. That part has to be correct on the right side. Okay, so then those vocab that we had talked about. So remember, in this, I'm going to fill in the bottom blank here. In an ellipse, A is the bigger value. So whatever the bigger value is A. And then C squared equals A squared minus B squared. And so I used the words earlier about major axis and minor axis, and that's just kind of the big and the small. So since A has to be the bigger number, then the major axis length would actually be 2A. Think of it almost like a radius. There'd be A in one direction, A in the other direction for 2A. The minor axis length would be 2B. All right, so major vertices use A, minor vertices use B. All right, and then the foci lie on the major axis. So the way that those are, and use the letter C, the way that the foci are aligned are always on the major axis. Now, in the MyMathLab homework, it doesn't use major and minor vertices. It only asks for vertices, and that would be the major. Okay, so our book does not distinguish between major and minor. They just ask for vertices, so it's only asking for the two major vertices. All right, so let's do an example here. You're going to have one just like this on in the homework. So here's a ellipse. The equation's given to us, and so it says sketch it. So I mean, right away, it's already done. We can tell that this is a vertical one. Why is it vertical? Because the bigger number's under y. And so A would be 5 and B would be 3. Pretty sure I did this example in our other video. Now, the center, that's one thing we didn't talk about, is that, the center, this ellipse can be shifted around. So while looking at our equation, just like every other translation the entire year, oh, that must have been shifted right 4 and down 2. So my center is at 4, -2. So if I were drawing this, I could go 4, -2, and that would be my center. And now I have enough information to make a good sketch. If A is 5 and it's vertical, I'm just going to go up 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. And then B is 3, so in the minor direction, we're going to go 1, 2, 3, and 1, 2, 3. And really, if all we asked for was the graph, we're done. We can just kind of connect the dots. It's kind of like making a circle. You got to make it smooth, no sharp points. We don't have any other way to make you do a really good picture. All we got to do is just clearly mark your major vertices and your minor vertices and just make it look like an oval, an ellipse, right? And that would be the sketch. All right, but now we're going to actually analyze the numbers. So the major axis length is always double the A, so that would just be 10. The minor axis length is double the minor, so 6. Kind of like the big diameter and the small diameter. All right, and then the major vertices, or what our book will call just the vertices, well, I can see them visually, but if I really needed to calculate them, from my center of 4 comma -2, I'm just going from the -2 up and down the major A value of 5. So, which of course would be 4 comma 3 and 4 comma -7 would be my two vertices. And then my minor vertices, I guess, would be kind of the other direction. It'd be 4 and then plus or minus the minor value of 3 comma -2, which of course would give us, what would that be? We'd have 7 comma -2 and 1 comma, -2, which of course I can just see from the graph, but in case the numbers are ever ugly or off the graph, we could use that. All right, and so notice we don't really need the foci in order to draw. It's more just an analysis. Now, of course, we gave you another one with a nice 3, 4, 5. C squared equals 25 minus 9. So C is 4. And so those 4 units are going to be up and down in the major direction, 1, 2, 3, 4, and 1, 2, 3, 4. And so again, the foci would just be 4 comma, and then from the center of -2, plus or minus those 4 units. So that would be 4 comma 2 and 4 comma -6. All right, and so we're not always going to have nice numbers like a 3, 4, 5 right triangle. So if it's, root 17 or whatever else, just write down the value like anything else. Okay, so that's a full analysis. And now let's do 2 more examples real quick. Write an equation for an ellipse with a focus at -4, 0 and major vertices at plus or minus 5, 0. So just as a quick sketch, you go, all right, well, if the major vertices are at plus or minus 5, 0, well, that tells me 2 things. That tells me that it's centered at the origin, which is nice. So sometimes I just make a little template right now. X squared over something, y squared over something equals 1. My major vertices are at plus or minus 5, so I know A equals 5, so this is 25 in the horizontal direction. And now, since one of the foci is at -4, well, symmetrically, the other foci have to be a +4. That tells me that C equals 4, and I'm pretty sure we have another. So C squared, 4 squared, equals A squared minus B squared. And we're not very creative right now for you. So we have 16 equals 25 minus b squared. And so b squared equals 9 and b equals 3. So for the b squared, that's going to go into the equation 9. And really, since the problem says, what's your equation, we're done. We didn't really even need to technically know what the b value was. We just needed to know what b squared was. All right, and lastly, write an equation for an ellipse with foci. So now the foci are given, and the major axis length is given. So, okay, well, if the foci are at 0, 2 and 0, -2, that tells me, again, the center is at 0, 0. You're welcome. So x squared over plus y squared over equals 1. And then we know it's vertically aligned. So if the major axis length is 8, that means A equals 4. Remember, the length is double. So therefore, A squared of 16 goes under the y. So 16 goes under y squared. And then if the foci are at 2 or -2, that tells me C equals 2. So if I have C squared equals A squared minus B squared, that gives me 4 equals 16 minus b squared. And again, we only need to know what b squared is. In this case, it's 12. So b squared must be 12, and that's the equation. Again, if these problems are only asking for the equation, we can be kind of that quick and sloppy about it. All right. So again, I know it's been a lot of videos for today. Thank you for watching. And then now you should be able to work on the My Math Lab problems, and good luck. Have a good day.